Okay, so hello, good day. Okay, so today we want to look at differentiation of trigonometric function. Okay, our trig functions like sine x, cos x, and tan x. So things like that. So we want to look at their differentiation. Okay, let's say y is equals to, or f of x is equals to sine x. Okay, so what is the differentiation from the first principle? Okay, from the first principle, we know that our f prime of x, which is our differentiation, which is the y dx, is going to be the limiting value as the x tends to 0 of f of x plus dx delta x minus f of x all over delta x, right? So that's the formula we're going to apply. Okay, so when we want to find f of x plus dx, whenever we find x, we replace it with x plus delta x, right? Okay, so this is going to be the limit as the x tends to 0 sine x plus delta x, that's f of x plus dx, then minus sine x, okay, all over delta x, right? So we're going to do it like this. Now, if you remember, we did some derivation of addition to product of trigonometric functions. Like when we say sine A plus B, we said it is sine A cos B, right? Plus cos A sine B, cos A sine B. If you remember these ones, right? And when we say sine A minus B, that will be sine A cos B minus cos A sine B, right? So if we subtract these two, we are going to have sine A plus B minus sine A minus B. That's going to be two of this, right? That is this one minus this. So that one will be gone. Then we have cos A sine B minus cos A sine B. So that will be what? 2 cos A sine B, right? So we now derive what A and B are. And A plus B, we represent it with C, and A minus B, represent it with D. So that from here we can find A plus B. When we add this, we have 2A will be C plus D, right? And when we subtract 2B, it will become C minus D, where A here is half of C plus D, right? And here, what happens here? B is what? Half of C minus D, right? C minus D, right? So we will now replace everything here. So what we have done here is this particular formula now. 2, that is sine A plus B now, sine C minus sine D is now 2 cos A. A is now half of C plus D, right? Then sine, then this is half of C minus D. If you remember, we derived this the last time in one of our videos down there, right? So we are going to use this to now substitute for this, right? So our f prime of x is going to be the limiting value as the x tends to 0. Then where we have c is now x plus dx. Where we have d is now x, right? So this is now going to be 2 cos half of c. C is now x plus dx. Then d is what? X, right? Plus x. Then sine half of c is now x plus dx. Then d is what? X. Okay? Everything divided by delta x. So that will now be limiting value as delta s tends to 0 So if you add this together, you are going to have 2 cos half of 2x plus delta x. When you add x and x, right? And here, when you subtract this, you're only left with delta x. Sine half of what? Delta x, right? Or you can write it as delta x over 2. So save space, delta x over 2. Okay? So this is now divided by delta x. Okay? So there is something in limits. There is a particular formula in limits that says the limit of sine A all over A as A tends to 0 is equals to 1. There is a particular formula that says limit of sine A all over A is going to be 1. Right? So this particular limit, we are going to apply this formula here. Okay, if you look at this very well, you will see that if we divide this one by 2, we can also multiply it by 2. You can say divide by 2 and multiply by 2. Right? So when we do that, it will be similar to something like this. Right? Such that this one is delta s divided by 2. This one is also delta s divided by 2. And of course, these 2 can cancel these 2 at this point, right? So this is now the limit as delta s tends to 0. Of course, 1 over 2, 2x plus delta x sine delta x over 2 all over delta x all over 2. So this particular expression here is equal to 1, right? Okay, so this is now, when we now substitute this here, then this one will come 1 here. So we have the limit as delta x tends to 0, of course 1 all over 2, 2x plus dx, delta x. So the limits can be split into the different versions, right? Of sine delta x all over 2, then delta x all over 2, right? So this is now going to be, now when you substitute 0 here, then this one is going to be 1 here. So it's going to be cos 1 all over 2, 2x plus 0, while this one will be 1. Alright? Okay, so this is now going to be cos 2, this is now 2x plus 0, that's 2x. 2x, this is now going to cos this. The end of it is going to be cos x. Right? Okay, so this is now the differentiation of sine x. So normally, so this is now, anytime we are now asked to differentiate sine x, we know it's going to give us cos x. Right? Okay, so this is how we go about this. Thank you. Now let's lecture consider of cos x. Thank you.